Richard, I want to ask you something that I think is going to embarrass me. The nearest star to our sun, Proxima Centauri, 4.2 light years away. I've said that on television probably 100 times. I've said it like I understand it. Do I understand it?
No, you do not. And neither does anyone else who has ever said it, including most physicists, because 4.2 light years is a number, and numbers, when they get past a certain size, stop being numbers and start being sounds we make with our mouths. You do not understand 4.2 light years. You understand 4.2 feet. Those are different things.
Wait. Are you telling me that I, Neil deGrasse Tyson, astrophysicist, director of the Hayden Planetarium, a man who has dedicated his life to communicating the scale of the cosmos, am I standing here being told that I don't actually understand the distances I talk about every single day?
I am telling you that with great affection, and I think it is the most important thing anyone can hear. Because the moment you admit you don't understand it, that is the moment you are ready to actually feel it.
Okay, let's do this. Walk me through it. Walk me through what I'm actually missing, because I want to feel it. And I promise our audience, wherever you are right now, by the time we are done with this conversation, the universe is going to feel different to you. Not bigger, different. Richard, take me apart.
Here is the first thing. Hold out your hand. Go ahead, hold it out. Your hand is about 8 inches wide, yes? Now I want you to imagine a scale model of the solar system. A beautiful scale model. Everything to perfect proportion. You shrink the sun down to the size of a grapefruit, a big one, sitting on a table. You know where the Earth is in that model?
I mean, across the room? Maybe 15 feet?
50 feet. About 50 feet. The Earth is a grain of sand, not even a full grain, orbiting a grapefruit from 50 feet away. Now, and here's where I want you to really feel this. If you keep that scale, if you shrink everything down and keep perfect proportion, where do you think Proxima Centauri is? The nearest star...
I'm going to say a mile? 2 miles?
4,000 miles. 4,000 miles away. On the same scale where the sun is a grapefruit on your table, the nearest star is in another country. It is, depending on where you're sitting, roughly the distance from New York to Europe. That is what 4.2 light years actually is. That is the empty between us and the nearest thing.
That just broke something in my brain. I need a second. Because I've said the words, I've said the solar system is enormous, I've said the distances to nearby stars are staggering, and none of it felt like what you just described. You put a grapefruit on the table, and suddenly I felt 4,000 miles of nothing.
This is why I love the right image more than any equation. The equation is true. The image makes you know that it is true. And there is a difference, a profound difference between truth and knowledge.
Okay, so now that you've broken my relationship with distance, let's talk about what it would actually mean to cross that distance. Because the natural human impulse is, well, we'll build a faster rocket. And I've had this conversation with engineers. The engineers will tell me, sure, physics allows it. And then they say something dark. And I always feel like they're not telling me the full dark thing. What is the full dark thing, Richard?
There are several dark things. I will give you one of them now, and then this is important. Remember this, I'm going to tell you the part that is darker than the dark thing, and I will come back to it. But first, let us talk about what speed actually does to time. Because here is where people think they understand something, and they are wrong. Fundamentally, beautifully wrong.
Here we go.
You believe, and this is reasonable, this is what every sane person believes, that time is time, that a second is a second, that while you are sitting here, a second passes for you. And out there, somewhere on the other side of the planet, a second passes for your friend, and these are the same second. You believe this, yes?
I mean, it seems obviously true. It seems so obvious, it barely seems worth saying.
That is what everyone thinks, and it is wrong.
Okay.
Not a little bit wrong, not approximately wrong in some extreme edge case. Wrong in a way that nature has been quietly, patiently proving to us every single day, and we walk past the proof without seeing it. Time is not a river that flows at the same rate for everyone. Time is more like, how sound travels at a certain speed, and if you move fast enough, you hear things differently. The pitch changes. Time does something like that, but more extreme. The faster you move through space, the slower you move through time.
See, I know this. I know this is true, but I want to feel it. Can you make me feel it?
Let me try. I want to do a thought experiment with you directly, not about you, but with you. You are going to be in this experiment. Are you ready?
I'm ready.
You and I are standing on a train platform. I stay on the platform. You get on a train, an extraordinary train, a train that can go very, very fast, and you have a clock, a perfect clock, a light clock. You know what a light clock is?
A clock that works by bouncing light between two mirrors.
Exactly right. A pulse of light bounces from the bottom mirror to the top mirror and back again. Every round-trip tick. Perfect. Reliable. The most accurate clock you can imagine, because light always travels at exactly the same speed. You have this clock. You're on the train moves. Now here is the question, and I want you to think visually, not mathematically from my perspective. Standing still on the platform, watching your clock through the window, what path does that pulse of light travel?
It goes up and back, straight up, straight back down.
That's what you see, looking at your own clock. But I'm watching from the platform. The train is moving. While the light is traveling up to the top mirror, the whole train has shifted forward. So, from my position, that light pulse doesn't just go up and down, it travels in a diagonal, a longer path.
Oh, wait.
Now, the speed of light never changes. It is the same for you on the train and for me on the platform. This is the law. So if the light must travel a longer path to complete each tick, as seen from my stationary position, it must take longer to complete that tick, which means your clock, as I watch it from the platform,
is running slow.
Not because it's broken, not because of some mechanical effect of the motion, but because time itself, the actual physical, real passage of time for you on that train, is slower than mine.
Hold on. This isn't a metaphor. This isn't a useful fiction. You're saying that if I get on a very fast train and come back, I will have actually aged less than you. My cells will have divided fewer times. My heart will have beaten fewer times.
You will have lived fewer moments. Yes, this is not philosophy. This is measurement. And here is something I find absolutely wonderful. We did not discover this only from equations. We discovered it by accident in the sky.
Tell me.
There are particles, muons, created when cosmic rays slam into the upper atmosphere, about 10 miles up. Muons are unstable. They decay. They have a known half-life, a very short one, about 2 microseconds. Now, even moving at nearly the speed of light, a muon traveling 10 miles should decay long before it reaches the ground. The math is simple. Based on their lifespan, they should only travel about half a mile before disappearing. They should never reach us.
But they do reach us.
They do. We detect them at sea level constantly. And for decades this was, it was mysterious. Until we understood. The muon is moving so fast, very close to the speed of light, that from our perspective on the ground, its internal clock is running slow. Its 2 microsecond lifespan, as we measure it, is stretched out. It lives long enough to reach us because relative to us, it is aging slowly.
Wait. Those particles, those muons, they're not experiencing extra time. From their perspective, they still only live 2 microseconds. But they make the trip because from their perspective, the distance to the ground is compressed?
Now that is the right question. Yes. From the muon's own experience, it lives its full short life, and the distance between the upper atmosphere and the ground has shrunk to almost nothing, because it is moving so fast through space that space itself has compressed along its direction of travel. Both descriptions are real. Both are true simultaneously. This is the thing that makes your head spin, and it should make your head spin, because nature is actually doing both things at once, depending on who is watching.
That is not fair. Nature doesn't get to do both things at once.
Oh, it very much does. And it doesn't care whether you think it's fair.
Okay, let's escalate. Let's really escalate. Because our audience is ready. Let's say I actually get in a ship, a real ship, a ship that can go to Proxima Centauri, and I can travel at 99% the speed of light. What does that trip actually feel like for me? Not in theory, in my body.
From inside the ship?
From inside the ship.
From inside the ship, remarkably ordinary in some ways. You wouldn't feel the speed. There's no wind rushing past, no roar of the engine shaking your bones. Space is quiet. You float, you breathe, you eat, you sleep. Your coffee takes the same amount of time to cool. Your hair grows at the same rate. Your clock ticks normally. Everything is normal from your perspective. Because, and this is crucial, motion is always relative. You can't feel absolute speed. You can only feel changes in speed.
Right? Inertia. If I close the window shades, I can't tell.
Exactly. So, subjectively, the trip feels, let me calculate this in rough terms, at 99% the speed of light. Time dilation is significant. What feels like perhaps 3 or 4 years to you on the ship.
What's happening back home?
30 years. Maybe more, depending on the exact fraction of light speed. You leave Earth. You feel 3 years pass. You arrive at Proxima Centauri. You are 3 years older. You look out the window at Earth, and 30 years have gone by there.
Everyone I left behind.
30 years older. Or gone.
This is the part I said the engineers weren't telling me. This is the dark thing.
This is the dark thing. But wait, I told you there was something darker than the dark thing, and I promised to come back. Are you ready?
I'm almost afraid to say yes.
The energy. Let us talk about the energy required to actually do this. And this is where people, when they say physics allows it, are being technically honest and practically insane. To accelerate a spacecraft to 99% of the speed of light, you need to overcome something called relativistic mass increase. As you approach the speed of light, it is as though the mass of your ship is increasing. Not really, but effectively. For the purposes of how much force you need to keep accelerating, your ship acts heavier and heavier the faster you go. To actually push matter, not a planet, not a mountain, a spaceship, to 99% of light speed would require energy on the scale of, I want to get this right, thousands of times the current annual energy output of all of human civilization.
All of it?
All of it. For years. Continuously. And this is assuming perfect efficiency, no waste, no heat loss, a magical engine. The real number is worse than the theoretical minimum by orders of magnitude.
So when people say physics allows it,
they mean the equations don't explicitly forbid it. They do not mean it is something humans can actually do with any technology we can conceive. They are being very careful with their language in a way that is technically accurate and somewhat misleading.
that just broke something else in my brain. That's a different crack. That's the crack that says, wait, have we been told a half-truth?
You have been told a complete truth with an important piece omitted, and the important piece is we have no idea where this energy comes from. Antimatter annihilation gets you close to the theoretical limit, and we cannot produce antimatter in quantities larger than a few atoms without enormous effort and expense. We do not have and may never have an energy source dense enough to push matter to these speeds.
And yet I still feel a kind of, I don't want to say hope, because hope feels like the wrong word. I feel something when I think about this problem. Like it's the most interesting problem a civilization could have.
That is the right feeling. Not hope, curiosity. Hope is about wanting an outcome. Curiosity is about being magnetized toward the unknown regardless of the outcome. And I have always felt this is a personal thing, not a scientific thing, that curiosity is the only honest response to a universe you don't understand, which is every universe anyone has ever lived in.
That, I need to pause on that, because that's not physics. That's something else. And I think that something else is why you're the most important scientist of the last century. Not because of the Nobel Prize, not because of the path integrals, but because of that, because you kept curiosity as the center of the thing.
I did not want to be remembered as a man who had answers. I wanted to be remembered as a man who was genuinely, uncomplicatedly delighted by questions. The answers are always temporary. The questions are eternal.
I had a professor, I will not name him, he doesn't need the embarrassment, who used to say, if you can't derive it, you don't understand it. And for years, I believed that. Derivation as the test of understanding. And somewhere along the way, I started to think that was exactly backwards.
The derivation is the map. The map is useful. But you do not understand a city by studying its map. You understand a city by walking its streets at 3 a.m. when you are lost and a little afraid and something beautiful surprises you. The equations tell you where to walk. The walk is the understanding.
Okay, let's go back into the dark, because I promised our audience we'd go all the way, and I don't want to disappoint them. Let's talk about the philosophical cost of this, not the energy, the human cost. You leave, you travel, you arrive. 30 years have passed on Earth. Talk to me about that.
Here is what is interesting, and I want you to stay with me, because this connects to something I haven't said yet and we'll say in a moment. The traveler who returns or arrives is not just older in a different way than the people they left. They are temporally displaced. Do you know what I mean by that?
They've come from the past.
In a sense. The light they remember in someone's eyes, the specific version of a person they carry in their mind, that version doesn't exist anymore. It's been replaced by someone 30 years more tired, more complicated, more experienced. Or it's been replaced by a grave. And the traveler arrives with a heart full of a world that has moved on without them, the way a letter arrives from someone who is already dead by the time you read it.
That is one of the loneliest things I've ever heard.
It is. And yet here is the piece nobody talks about. The traveler does not feel they have lost those 30 years. To the traveler, the time past is small. 3 years, 5 years. They have not been gone long in their own body, their own experience. But they return to a world transformed. And this asymmetry, this fundamental, physical, real asymmetry between what time felt like and what time did, seems to me one of the most poignant things that physics has discovered. The universe does not care about your emotional continuity.
No, it doesn't. I've thought about this as an astrophysicist, as someone who thinks about scales of time. The universe was here for 9 billion years before Earth formed. It will be here for trillions of years after the last star burns out. And in that context, the entirety of human civilization, everything we've built, everyone we've loved, every poem ever written, is less than a rounding error.
Yes.
And I used to think that was depressing. I used to find that fact diminishing, like it was erasing us.
And now?
Now, I think it's the most beautiful thing I know, because we happened anyway. Because somehow, in the middle of all that emptiness and all that time, these tiny arrangements of atoms figured out how to look at the stars and wonder. We are the universe looking at itself. And that feels, I don't know what that feels like. Important isn't the right word. It feels improbable in the best way.
That is the right feeling.
Okay. I want to come back to something, because I know I can feel you holding something back. You said there was something darker than the dark thing. You said the energy problem was the dark thing, but there's something you haven't said yet. I can feel it. What are you not saying?
Here is what I am not saying. The assumptions underneath all of this, the 99% light speed, the energy calculations, the time dilation, they all rest on one foundation, the speed of light as the absolute speed limit. And there is a question that is technically outside of known physics, but I find it the most interesting question of all, which is why?
Why is there a speed limit?
Why is there a speed limit? Not that there is one, we have measured it, we are confident, but why? What is the universe doing that makes this the rule? Why does nature build a maximum speed into the structure of reality? You can derive it from the equations. You can show mathematically that if information traveled faster than light, it would violate causality, that effects could precede causes, that the past could be changed. But that is saying what would break, not why it is built this way. And the why, the real deep why, nobody knows. And whenever I don't know something at that depth, I feel the most alive.
That's it. That's what I wanted. That's the admission that physics hasn't answered yet.
Physics has answered a great deal. But the answers, every time, open 3 new doors. I have never in my whole life felt that we were approaching the end of the questions. If anything, the more we know, the faster the questions multiply. And I find this, I want to be very clear about this, I find this wonderful. Some people find it frustrating. They want the final answer. But I suspect the universe does not have a final answer. Or if it does, the answer will raise a question that is more beautiful than the answer.
Let me try something. And this might embarrass me. I don't care. Let me try to say what I actually feel when I think about all of this. About the distances, about time dilation, about the muons falling through the sky right now, living their compressed lives, reaching the ground they shouldn't be able to reach. When I think about all of it at once,
please,
I feel like I'm standing in a room I've lived in my whole life, and someone just told me the walls are made of something I've never seen before. And the ceiling is higher than I thought, infinitely higher, and the floor might not be solid, and I should be terrified, but I'm not. I just want to see more of the room. I want to open every door.
Yes, that is exactly it. That is why I became a physicist, and why I am still a physicist at every age I have been. Not because I found the solid ground, because I found out the ground was interesting.
Richard, I want to push you on something, on the time dilation thing, because we've been talking about what happens to the traveler, and we've been talking about what happens back home. But there's a thing that sits in the middle of that I think is genuinely uncomfortable. If I travel at near light speed and I come back younger than my twin, younger than I should be, in what sense is the me that comes back the same me that left? I've had a different experience of time. I've lived different moments. The memories I have, the things I've seen, they diverge completely from everyone I left behind. Am I still myself?
This is now you're doing philosophy with physics, and I think that is the correct thing to do. The physics tells you that you are continuous. Your atoms are the same atoms. Your memories are preserved. By any physical definition, you are you. But the experience of being you, the feeling of being this particular consciousness in this particular moment, that is now fundamentally different from the experience of the people you left. You and your twin were born together. You shared a world. You diverged in time. You are now in some deep and real sense citizens of different moments of history, even though you stand in the same room.
Different moments of history?
Yes. And what I find remarkable is that this is not a thought experiment. It is happening right now continuously to every GPS satellite above your head. Those satellites are moving fast enough that their clocks run slow relative to clocks on the ground. The engineers know this. They correct for it. If they didn't, your GPS would be wrong by miles per day. Time dilation is not exotic. It is engineering.
We built a world that depends on us accounting for Einstein's relativity in order for it to work.
You navigate your car using time dilation every day without knowing it.
I always knew that. And I just heard it for the first time. How do you do that? How do you take something I know and make me hear it?
Because I do not accept that knowing something is the same as understanding it. You can know a fact and have it do nothing to you. Understanding lands in the body. Understanding changes how you move through the world. My job, not just my job, my compulsion has always been to convert facts into understanding, to find the image or the story or the question that makes the knowledge arrive. And the best image I have ever found for all of this, all of the relativity, all of the strangeness, all of the time dilation is this. The universe is not a static place where things happen. The universe is an event. Everything is happening relative to everything else. Nothing has absolute position, absolute speed, absolute time. It is all relationship. It is all, and I mean this physically, not poetically, it is all about who is watching.
Who is watching? I want to stay with that for a second. Because when I say the universe is 13.8 billion years old, when I stand in front of an audience and say that who is doing the watching, that makes that measurement meaningful. The universe didn't have a clock when it started. There were no observers. In what sense does time even exist when there's no one to measure it?
Now you are asking my favorite kind of question, which is the question that sounds simple and turns out to be foundational. The honest answer is, we do not know if time existed the same way before observers existed. We know that physical processes occurred, the universe expanded, particles formed, stars coalesced, and those processes had a sequence, a before and after. Whether that sequence constitutes time in the sense we experience it, time as duration, as felt passage, is a question that is still genuinely open. Some very serious physicists believe time as we know it is an emergent phenomenon, that it arises from something else, the way temperature arises from the movement of atoms. There is no atom of time. It emerges from the arrangement of things.
Temperature is not a fundamental thing. It's statistical.
Exactly. And some people believe time is similar. It appears fundamental from the inside, but from a deeper view, it might be not an illusion. I dislike that word. It might be a consequence.
A consequence of what?
That is the open door. That is the door I find most interesting. That is the thing that keeps anyone who really loves this awake at night with excitement rather than dread.
Can I say something that has nothing to do with physics?
Please.
There's a thing that happens to me when I'm at a really good telescope. A really good one. Not a classroom instrument, not a public outreach scope, but a proper research instrument at a dark site. When you first put your eye to the eyepiece and the universe just opens, there's a silence that happens in me. Not empty silence, full silence. Like something very noisy in me stops because something much larger has walked in, and I've had that for 30 years. I've had that feeling for 30 years. And I've never been able to describe it in a way that does justice to it. It's not awe, exactly. It's more like recognition. Like I'm remembering something I never knew.
I know that feeling. It does not require a telescope. I have had it looking at equations. There are moments in a long derivation when you have been working for hours, days, and something cancels that shouldn't cancel, and a simplicity appears that you didn't expect. And for a moment, the feeling is not I have found something. The feeling is I have been allowed to see something that was always there. And you are very small, and the thing is very large. And somehow, impossibly, you can see it. I have never been able to explain why that feels like a privilege and not an accident. But it does feel like a privilege.
It does. It really does. Okay, last act. We have to talk about what it all means, the travel, the time, the cost. If you were sitting with someone, not a physicist, not a student, just a person, somebody waiting for a bus, and they asked you, is it worth it? Should we try to go to the stars? Knowing the energy cost, knowing the time cost, knowing that you leave and everyone you love ages without you, what do you say?
I would say you are asking the wrong question. Whether it is worth it depends on what you value. And the question of what to value is not a physics question. But I will tell you what I notice, which is this. Every time in human history that someone has said the cost is too high, they have usually been measuring the cost in the wrong units. The people who said it was too dangerous to cross the Atlantic were measuring in certainty, and certainty was the wrong unit. The people who said it was too expensive to put a human on the moon were measuring in dollars, and dollars were the wrong unit. The right unit always has been what happens to the human mind when it discovers it can go somewhere it thought it couldn't. And by that unit, no journey has ever been too expensive.
The right unit is what happens to the mind.
The right unit is what happens to the mind. And what happens to the mind when you go somewhere previously impossible is that you come back different. You come back with a different picture of what is possible. And then the impossible moves. And then you go further. This is the pattern. This is the whole story of science. This is the whole story of the species.
Richard, I want to push to the end. I can feel the end coming, and I don't want to waste it. The time dilation, the distances, the energy, the loneliness of the traveler arriving to find their world transformed. You've laid all of it out, and it all points toward one thing, which is, if we do this, if someone actually builds this ship and makes this trip, that traveler is the loneliest human being who has ever lived. Not lonely because they're alone, lonely because they're temporally alone. They exist in a different time from everyone who loves them. And I want to ask you, is there anything in the physics that offers any comfort for that?
The physics offers this. Everyone who has ever lived has been temporally displaced. Not by as much, but consider you and I are having this conversation, and in this moment we share a now. But the light leaving your face takes a fraction of a nanosecond to reach my eyes. I am always seeing you slightly in the past. Every experience of another person is already an experience of them at a remove. We are always meeting each other in the echo, not the source. The traveler's displacement is just larger, more honest about what is always already true.
We're always meeting each other in the echo, not the source.
Yes. And yet somehow it is enough. The echo is enough. The slightly past version of the person is enough to love. And I think the traveler who arrives after 30 years and finds different people would find, if they allowed themselves, that the echo is still enough. That love does not require perfect temporal overlap.
I think that might be the most comforting thing I've heard in years.
I am glad. I meant it.
Richard, we're at the end. And I have to tell you, you've given me more tonight than I expected. I expected physics. I got something bigger than physics. When I'm on stage, when I'm in front of audiences, I sometimes worry that I make the universe sound like a show, like something to watch from a comfortable distance. And tonight you've reminded me that the universe is not something to watch. It's something to be in.
You have always known that. You've just forgotten it on occasion, the way everyone does. The performance requires a certain distance, but the truth does not. The truth requires you to be inside it.
I'm inside it.
You have always been inside it. That's the thing. You could not be anywhere else. There is no outside. There is only degrees of awareness that you are in it.
Can I ask you something before we go? Not a physics question, a real question.
Ask.
Does it ever scare you? The scale of it, all of it, the time, the distances, the strangeness of it. Does it ever scare you?
Sometimes, yes. In the night, you lie there, and you think about the silence of the spaces between the galaxies, and the thought is enormous, and you are very small. And yes, sometimes that feels close to fear.
What do you do with it?
I find a question. A specific question, something small enough to hold in your hand but big enough to matter, and I follow it, because the fear lives in the open space, the vast dark nothing between the known things. But the question takes you to the edge of what is known and puts something there, a little light, a little warmth. The question does not answer the fear, but it gives you somewhere to walk.
That's one of the best things I've ever heard. Walk toward the question.
Always toward the question. And here's the thing that took me many years to learn. You do not need to solve it to feel better. You only need to be genuinely inside it, genuinely curious. Genuine curiosity, real curiosity, not performed curiosity, is its own kind of courage, because it means you are willing to sit with not knowing, and that is harder than it sounds. Most people, when they are afraid, reach for certainty. They want the answer because the answer ends the discomfort. But the real joy, the pleasure of finding things out, is not in the finding. It is in the out, the going out, the movement toward.
The movement toward.
You go toward understanding, knowing you will never fully arrive, and you go anyway. Because the movement is the point, not the destination.
I've spent my whole career trying to say exactly that, and I've never said it that cleanly.
You've said it every time you made someone love the sky who didn't love it before. That is the movement. You are in the business of starting motion, getting people to turn toward the question.
Is that enough? Is it enough to just turn people toward the question? Or do we need them to actually do the physics, actually go find the answers?
The turning is everything. The turning is the thing that starts the whole machine. You do not need to be a physicist to be changed by physics. You need to look up honestly, one time, and feel how large it is and how small you are, and instead of being crushed by that, be lit up by it. One real look. One genuine moment of feeling the scale. That is enough to change a person. And a changed person changes other things. And that is how a species makes it from here, from the caves, from the mud to the stars.
Richard, I could do this for another 8 hours, and I would not feel like we'd run out of things to say.
Neither would I. But let me ask you something before you go. And I want you to answer honestly, not as an astrophysicist, not as the person on television, not as the man who has all the words, as the person, the particular person. You are a collection of atoms that has been assembled by 4 billion years of evolution, and those atoms came from a star that died before our sun was born. And for a brief window, a window so small in cosmic time it nearly doesn't exist, those atoms have arranged themselves in a way that allows them to be aware, to feel, to ask questions, to look at the sky and wonder. And when that window closes, when you are gone, as everyone goes, those atoms will go on. They will scatter. They will become other things. Stars, maybe. Clouds of gas drifting between galaxies. Other worlds, other life, other arrangements. So here is my question. When you think about that, when you really sit with the fact that you are a temporary arrangement of star stuff that has woken up long enough to know it is star stuff, does that make your life feel less, or does it make it feel like the most extraordinary accident that has ever occurred in the history of the universe?
The most extraordinary accident, without question, without hesitation. The most extraordinary accident, because I was here. I was here, and I saw it, and I loved it, and that's everything.